Today we're going to add two more properties of exponents into our kind of toolkit here. And so first we're going to talk about negative exponents, and there's kind of some golden rules that I use with negative exponents. So one is we never evaluate integers, so numbers, not variables, to a negative exponent. Instead, I use the phrase cross the line, change the sign. Okay. So our rule with our negative exponent is that if I have a variable raised to a negative power, or even if it was an integer, I want to get rid of that negative exponent by writing it as 1 over that variable to the positive exponent. And if it was the other way around, so if I had x or 1 over a to the negative m, then I would move that a to the numerator and my exponent would become positive. So let's look at a few examples. If I had something like 3x to the negative third, y to the fourth. So another kind of important idea here is that each term here I'm going to look at separately. So 3 is its own term that's being multiplied by x to the negative third being multiplied by y to the fourth. The only term that I have an issue with right now is my x variable because it's being raised to a negative exponent, and we never leave a negative exponent. Okay, to have something fully simplified, it no longer would have any negative exponents in the expression. So this is all in the numerator, and the 3y to the fourth can stay in the numerator. I'm going to move x to the denominator, and once I cross that line, I've changed the sign. Okay, I move the term, if it's in the numerator, to the denominator, if it's in the denominator, to the numerator, and that's what's going to create a positive exponent for me. So that's a note we should make as well. A simplified expression contains only positive exponents. So when you're asked to simplify these expressions, that's a piece of it. I can't leave a negative exponent anywhere or else that expression is no longer simplified. Another example, if I had 2x to the fourth over y to the negative second, z to the second. This expression is fine as is, meaning I only have a single x term, single z term. I don't have any other properties to use here, but I can't leave this negative exponent and have it be simplified. So I'm going to move it to the numerator, giving me 2x to the fourth y squared, and the z squared can stay right where it is. It's perfectly content down here with a positive exponent. Now let me go back to kind of this first golden rule of never evaluate integers to negative exponents. What I mean is if I have something like 2 to the negative third, I cannot just make this, like a lot of students want to make this negative 8. 2 cubed is 8, oh, it's negative, so it's negative 8. That's not true. If we follow this rule, that means this is in the numerator, I'm going to move it to the denominator and make it positive. That means that 2 to the negative third is 1 over 2 cubed, or 1/8 when I simplify it. So I never evaluate things that have negative exponents. First, I make the exponent positive, and then evaluate it wherever the positive exponent is located. Okay. The other property that we have, and I'm going to start with an example actually here, is our 0 exponent. So if I had, let's say, x to the 7th times x cubed over x to the 10th, and we use our properties of exponents to simplify that. So I go, okay, well, p-man multiplication here, I should add my exponents. Gives me x to the 10th over x to the 10th. And if I use my division property and subtract that, That's going to give me x to the 0 power. 10 subtract 10 is 0. Well, we know that anything over itself, so if I have something like 3 over 3, it's equal to 1. If I have x over x, it's going to equal 1. If I have x to the 10th over x to the 10th, it's going to equal 1. Okay, kind of seeing why this happens, here's something that's to the 0 power, we can see that that should be equivalent to 1. Anything, this is the easiest property because there's no evaluating to be done. Anything to the 0 power is 1. Okay, x to the 0 is 1. So let me give you another example of something that you might see. So here's a properties of exponents problem. This entire parentheses is being raised to the 0 power. So it doesn't matter if it's just a single term or all of this, anything raised to the 0 power is 1. So this is just 1. This entire parenthesis just becomes 1. Raised to the 0 power is 1. Then I would simplify the rest of the expression. 3 cubed is 27. X squared cubed is x to the 6. Y cubed. And 1 times this is just going to be this. So really it just kind of almost gets rid of it when I have it there. Okay, so let's look at a few examples and get some practice with these new properties. So first, here's that rule where I never evaluate integers that are raised to a negative exponent. So similar to this one up here. This does not mean it's a negative number. It means I can't simplify the negative exponents. I need to rewrite that with a positive exponent. Now I can evaluate it. Which is why if you put this into the calculator, you'd get like this weird decimal, and that really can confuse students. It's having this concept down. Same idea here. I can't evaluate that until I move it, make my exponent positive. Now I can evaluate 2 to the 5th is 32. And anything to the 0 power is 1. This page. Now, what I always say is I try to avoid, so in our notes, we're not going to be able to avoid negatives too much, but we can a little bit. I always do any other property that I can do first, and then at the last resort, I start moving negatives. So for example, here, I'm going to use p-man, right, and say, okay, this is multiplication, so I should add, and would give me 3 cubed. I didn't have to worry about the fact that that was a negative. I added my exponents, and then I evaluate. There'll be other times, so here if I go ahead and do p-man, gives me 4 to the negative 5th, I still have a negative. I need to deal with the fact that I have a negative by moving that term. We're not going to evaluate 4 to the 5th. Okay, and I've moved it and now I'm done. On 6, 8 to the 0 power, well, that's just 1. I have a negative exponent to deal with here, so I need to move it first. 3 squared we can do is 9. Same idea on 7 through 9. This is using a former property, right? So here I have, if I think p-man, I have a power to a power, I'm going to multiply. Multiplying my exponents gives me 2 to the negative 6. I need to first rewrite that before I can evaluate it. And I believe that's 64, 1/64. P-man, I multiply first. So 6 to the negative 2nd, 1 over 6 squared, 1 over 36. Now this one's, this is interesting. So I want to make sure that I also include the negative. So I'm going to multiply this, but I'm going to leave it as negative 2 to the negative 3rd. because I want to make sure the negative gets included with that negative 1 that's out there. So then when I write negative 2 cubed in the denominator, that's when I'm evaluating. Because I have 3 factors of a negative, it's going to be negative 8 in my denominator. Moving to the bottom section of examples here, now we have exponents. So I'm going to do a couple and then I'll let you do a couple and then we'll look at some more challenging examples. So when I look at expressions, anytime I see 0, I'm basically eliminating that expression. Anytime I see a negative, I need to cross the line, change the sign. So let me just go down through this row here. 7, that's fine where it is. There's no negative exponent. I don't have to flip-flop the whole term. I'm just going to say, well, this is negative. I need to move it to the numerator to make it positive. Here's my simplified expression. On 13, x to the 0, well, that's just 1. Now, 3 is not being raised to the 0 power. Only the variable x is. So I have 3 times 1, or 3, and then I need to move this negative and make it positive to finish simplifying that expression. All of this is being raised to the 0 power. It's all just 1. I can eliminate it. This is negative. I need to make it positive by moving its location. Let's look at 20 real quick. I'm going to do an L and then I'll leave the top 4. On 20, I need to make sure that both the 3 and the x gets raised to a negative 3rd power. So I can either bring that in now, or I could have moved this up and then brought in the exponent, but it's important that the integers are treated separately. Now they're both going to be negative, so I'm going to have to flip them and write them in the numerator with a positive exponent. Now I can evaluate it, 27x cubed. On 21, now this one gets trickier than it looks. So I bring in this -2. Now, what I cannot do is evaluate this and call this -4, and I see students doing that all the time. I have negative exponents. I never evaluate integers raised to a negative exponent. I need to move this to the denominator and make it 2 squared. Okay, now I have a positive exponent, and I'll move this term as well and make it x squared. Okay, so I've moved these terms. Now they're in the denominator. Now I can evaluate this. So the 3y to the 5th is going to stay right where it is. No negative exponents, no issue there. 2 squared is positive 4x squared. Okay, there's 4 remaining problems here that I want you to try, and then check your work against the key in a moment. Okay, so check out 11, 12, 14, and 15. This one's a little tricky. Make sure -2 to the 4th would give us a positive 16. Only moving terms that are negative, the 8 staying on 12, the 3 staying on 11. Okay, now it's time to have some fun. Okay, so now we've essentially learned all of the properties of exponents, which means we can put it all together. So I'm going to do a couple of these, and then I'll let you try a couple as well. So I'll try some of the more challenging ones. So I'm going to start with this 3rd problem here. So when you get to a problem like this, first, anywhere you have parentheses, we need to deal with that. So I'm going to distribute in this, or bring in this -1 here to exponent of 2 here. Following properties of exponents really carefully. So remember, when I bring in a power and multiply, so this first parenthesis would become 3 to the 1st, -1 times -1. -3 times -1 makes that a positive exponent. Y to the -1st times, bringing in a 2 here, 2 squared, so that's going to give me 4, x squared squared, x to the 4th, y to the -3rd squared, y to the -6. Okay, so now I've brought in that exponent of 2. And in the denominator, bringing in an exponent of, so I could either move this, I can move this up and make it the outside exponent only. That would be the only one that would change with that move to a positive, or I kind of like to just leave it for the moment, because I'll show you what I mean, that I can get rid of negatives in kind of creative ways here. Because sometimes when I bring it in, like on the x variable, I'm going to have a positive there, and I don't want to move it up and move it back down. So gives me +4 and then y to the -4th. Now, the thing with these problems that I want you to be hyper alert of is these types of terms where you have integers raised to negative exponents. Never evaluate that. Don't make this 25 in the denominator. I've got to move that up. And so I usually go ahead and do that and kind of add it in and get rid of it in that location right away. Okay, number one thing to kind of be looking for in that first kind of step where you're starting to clear things up. So now what I'm going to do is I'm going to combine what I have in this numerator, and then I'll work from there. So I'm going to do some kind of color coding here. So I have, this is 25 times, I have 3 25 times 3 times 4. Or I have 25 times 3, 75, times 4 gives me 300. So I'll multiplying my three integers together. Remember, those aren't properties of exponents. I'm just multiplying the terms together. Gives me 300 for that term. Then I'm going to go to my x term. So I have x cubed and x to the fourth. P-man tells me that when I multiply exponents together, I'm adding. So adding those exponents gives me x to the seventh in the numerator. Then I have y to the negative first and y to the negative 6. Again, adding gives me y to the negative 7th over x to the fourth, y to the negative 4th. Now here's how I kind of get rid of the negatives for my variables if I can, if I have one in both the numerator and the denominator, without having to worry about moving them. I just move right into the quotient property where I say I have more x's here, so I'm going to do 7 subtract 4, and it's going to give me 3 x's in the numerator. Now for my y's, I have negative 7 and negative 4. Negative 4 is more than negative 7, so I'm going to subtract from here to here, which means my y's will end up in the denominator. And what I'm really doing here is negative 4 subtract negative 7. And this double negative means I really have negative 4 plus 7. So when I use that quotient property that we talked about on our last set of notes, where we take the larger number and subtract the smaller, we can do that with negative exponents. But when we subtract a negative, we have to remember that that's like addition, and it gives me y cubed here. Now the other option is writing this out again. So that kind of gives a shortcut. I could have also said, okay, so I have 300x cubed, and I could have flip-flopped those, moved the y to the fourth up, moved the y to the seventh down, and then gone like this. 7 subtract 4 is 3 left in the denominator. Okay, but this kind of gets rid of the negative and does the quotient property at once. If we always just go larger, subtract smaller, larger, subtract smaller. So let me do another example of that. I'm going to do the last one here. So again, anywhere I have an exponent outside, I don't worry about the fact that it's negative right now, because by multiplying in, it's going to also clear up some negatives along the way. So I'm just going to go ahead and bring all my exponents in and then work from there. So I have a to the positive 8th, negative times a negative, b to the negative 12th, bringing in this negative 2, a to the 6th, b to the negative 4th, times a to the negative 4th, b to the negative 4th. Okay, so now I've cleared those parentheses. I'm going to combine what I have in my denominator. So I'm going to say, okay, I have 6 a's here and negative 4 there. P-man tells me that when I multiply, I add. So numerator staying the same gives me a squared, combining those terms. Adding these together, I have b to the negative 8th. Now I'm at the quotient property step. So I have more a's in the numerator than I do the denominator. So subtracting 8 subtract 2 gives me 6 a's, and it would be in the numerator because that's where I had more, a larger exponent value. Now these are negative. So negative 8 is greater than negative 12. I'm going to subtract negative 8, subtract negative 12. My larger exponent was in the denominator, so b is going to live in the denominator, and I'm subtracting a negative, so it's like adding. It's going to give me b to the 4th. Okay, so now I want you to try the remaining kind of 3 more challenging problems and check your work against mine in a minute. Okay, so let's look at these problems. So on this first one, just to kind of talk through what I did, I actually did the quotient property first. Then I brought in the negative exponent, and everything was negative, so it all went to the denominator. On number 2, I brought in this negative 2, used the quotient property, and both m and n ended up in the denominator. This one's a little funny. So multiplying straight across here, I have 6, negative 30, 31 is a to the first. Then you get b to the first. A over a is just going to cancel out or give you a to the 0. 6/3 is 2 and leaves me with 1b.